Welcome guys once again to chapter number 7. We have already discussed part 1 and part 2. Let's talk about part 3 of chapter number 7, which is unguided media, which is wireless. Let's talk about unguided media. Unguided medium transport electromagnetic waves without using a physical conductor. This type of communication is often referred to as wireless communication. Signals are normally broadcasted through free space and thus available to anyone who has a device capable of receiving them. As you can see in the figure, it shows a part of electromagnetic spectrum ranging from 3 kHz to 900 terahertz used for wireless communication. Unguided signals can travel from source to destination in several ways. Number 1, we know about ground propagation, sky propagation, and line of sight propagation. Let's talk about these propagations. As you can see, number 1 is a ground propagation. Radio waves travel through the lowest portion of the atmosphere, hugging the earth. These low frequency signals emanate in all directions from the transmitter antenna and follows the curvature of the planet. Distance depends on the amount of power in the signal. The greater the power, the greater the distance. The second one is the sky propagation. High frequency radio waves radiate upwards into the ionosphere, the layers of atmosphere where particles exist as ions, and we already know that these ions are produced because of the radiation from the sun. We have 4 layers over here: D, E, F, 2 and F1. This type of transmission allows for greater distance with lower output power, so we don't need much power for these things. In the line of sight propagation, very high frequency signals are transmitted in straight line directed from antenna to antenna. Antenna must be directional, facing each other, and carry tall enough and either tall enough to close enough together not to be affected by the curvature of the earth. Line of sight propagation is tricky because radio transmission cannot be completely focused. This section of the electromagnetic spectrum defines as radio by government authorities. So let's talk about the electromagnetic spectrum by the government authorities. These bands are rated from low frequency. We'll talk about low frequencies till 300 kilohertz, which are used by the ground propagation, and then we'll use the medium frequency we'll go till very high frequency, which are used by sky waves, from 300 kilohertz to 300 megahertz, and from 300 megahertz onwards we'll see till 300 gigahertz that these are all line of sight. So the bands are like very low frequency, medium frequency, high frequency, very high frequency, ultra high frequency, super high frequency, and extremely high frequencies. We can divide the wireless transmission into 3 broad categories: radio waves, microwaves, and infrared waves. So the division is here: radio waves, microwaves, and infrared waves. Let's talk about radio waves first. Although there is no clear-cut demarcation between radio waves and microwaves, electromagnetic waves ranging in frequencies between 3 kHz to 1 GHz are normally called radio waves. So they are from 3 kHz to 1 GHz. Waves ranging in frequencies between 1 to 300 GHz are also called microwaves. However, the behavior of these waves rather than the frequencies is better criterion for classification. Radio waves for the most part are omnidirectional. Radio waves are omnidirectional. Omnidirectional means that they don't need any direction. When an antenna transmits radio waves, they are propagated in all directions. This means that the sending and receiving antenna do not have to be aligned. So they can be anywhere on the earth, and they can still receive the signal. A sending antenna sends waves that can be received by any receiving antenna. The omnidirectional property has a disadvantage too. The radio waves transmitted by one antenna are susceptible to interferences by another antenna that may send signal using the same frequency or band. Radio waves, particularly those waves that propagate in the sky mode, can travel long distances. This makes radio waves a good candidate for long distance broadcasting such as AM radios. Radio waves, particularly those of low and medium frequencies, can penetrate walls. These characteristics can be both an advantage and a disadvantage. It is an advantage because, for example, an AM radio can receive signals inside a building. It is a disadvantage because we cannot isolate a communication to just outside or inside of a building. The radio waves band is relatively narrow, just under 1 GHz compared to microwave band. When this band is divided into subbands, the subbands are also narrow, leading to a low data rate for digital communication. Almost the entire band is regulated by authorities, which is FCC. Using any part of the band requires permission from the authorities. Let's talk about unidirectional and directional antennas. First, we'll talk about omnidirectional. Radio waves are omnidirectional antennas that send out signals in all directions. Based on the wavelength, strength, and the purpose of transmission, we can have several types of antennas. The omnidirectional antenna has a application. Let's talk about the application. The omnidirectional characteristics of radio waves make them useful for multicasting, in which there is one sender but many receivers. AM and FM radio, television, cordless phones, paging are examples of multicasting. Let's talk about the microwaves. Electromagnetic waves between 1 to 300 GHz are also called microwaves. Microwaves are unidirectional. When an antenna transmits microwaves, they can be narrowly focused. This means that the sending and receiving antennas need to be aligned. The unidirectional property has an obvious advantage. A pair of antenna can be aligned without interfering with another pair of aligned antenna. The following describes such characteristics of microwave propagation. Let's talk about some characteristics. Microwave propagation is line of sight. Since the tower with the mounted antennas need to be in direct sight of each other, towers that are far apart need to be very tall. The curvature of the earth as well as other blocking obstacles do not allow two short towers to communicate by using microwaves. Repeaters are often used for longer distance communications. Number 2, very high frequency microwaves cannot penetrate walls. This characteristic can be a disadvantage if receivers are inside building. The microwave band is relatively wide, almost 299 GHz. Therefore, wider subbands can be assigned and a high data rate is possible. Use of certain portion of the band requires permission from authorities. So the two figures next to omnidirectional, they are unidirectional antennas. Let's talk about these unidirectional. Microwaves use unidirectional antennas that send out signals in one direction. Two types of antennas are used for microwave communication: a parabolic, which is a dish antenna, and the horn antenna. First, let's talk about the dish antenna or the parabolic. It's based on the geometry of parabola. Every line parallel to the line of symmetry, that means line of sight, reflects off the curve at angles such that all the lines intersect in a common point called focus, where we usually have L and B's. The parabolic dish works as a funnel, catching the wide range of waves and directing them to a common point. In this way, more of the signal is recovered that would be possible with a single point receiver. Outgoing transmissions are broadcasted through a horn aimed at the dish. The microwaves hit the dish and are deflected outwards in a reversal of the receipt path. The last one is a horn antenna. Looks like a gigantic scoop. Outgoing transmissions are broadcasted up a stem, looks like a handle, and deflected outwards in a series of narrow panel beams by a curved head. Received transmissions are collected by the scooped shape of the horn in a manner similar to the parabolic dish and are deflected down into the stem. Well, what's the applications? Microwaves used to their unidirectional properties are very useful when unicasting, means one-to-one. Communication is needed between the sender and the receiver. They are used in cell phones, satellite networks, and wireless LANs. Let's talk about the last one. It's called infrared. Infrared waves with frequencies from 300 GHz to 4 terahertz, means they are millimeter wavelengths, can be used for short range communication. Infrared waves having high frequencies cannot penetrate walls. The disadvantage characteristics prevent interference between one system and another. A short range communication system is one room cannot be affected by another system in the next room. When we use our infrared remote controls, we do not interfere with the use of the remote by our neighbors. However, this same characteristics makes infrared signals useless for long-range communication. In addition, we cannot use infrared waves outside a building because the sun rays can contain infrared waves that can interfere with the communication. Well then, what's the application of this infrared band? Almost 400 terahertz has an excellent potential for data transmission. Such a wide bandwidth can be used to transmit digital data with a very high data rate. The Infrared Data Association (IRDA), an association for sponsoring the use of infrared waves, has established standard for using these signals for communication between devices such as keyboards, mouse, PCs, and printers. For example, some manufacturers provide a special port called IRDA port that allows a wireless keyboard to communicate with a PC. The standard originally defined a data rate of 75 kilobits per second for a distance up to 8 meters. The recent standard defines data rate up to 4 megabits per second. Infrared signal defined by IRDA transmit through line of sight. The IRDA port on the keyboard needs to point to the PC for transmission to occur. So let's call off this chapter here. We are done with all the three parts of the transmission. We talked about wireless, we talked about the wide medium, and we discussed some of the characteristics and their application throughout the chapter. Till next time, we'll see you with chapter number 8. Inshallah, take care.